In this question, we are given the information that a farmer needs to design rectangular corrals for his cattle, like the diagram shown here. He has 720 meters of fencing and would like to have 2 internal fences, 1 and 2, and 3 equal enclosures, 1, 2, 3. How should he build the corral to maximize the area for his cows? In order to solve this problem, we first need to start by developing a function for the perimeter. If we label the 4 sides as x and these other 2 sides as y, we have a perimeter that's equal to 4x plus 2y. In addition, we know that the perimeter is equal to 720, so we can substitute 720 for p. And now we need to isolate for one of the variables. Let's isolate for y. To do so, we'll subtract 4x from both sides of the equation, and then finally divide by 2, such that we have 360 minus 2x. Now we need to come up with a function for the area. The area in this case is simply just x times y, length times width. And then again, we will substitute in our function for perimeter, 360 minus 2x, in for this y. Now we will distribute the x across the 360 and the negative 2x, and we now have 360x minus 2x squared. Changing the order so we have it in descending order of powers, we are now ready to go ahead and complete our square. Notice that we have a leading coefficient of negative 2, therefore we need to factor that negative 2 from our first 2 terms. When we do so, we're left with x squared minus 180x in the brackets. Next, we'll take the negative 180, we'll divide it in half to give us negative 90, and then we'll square it, which of course gives us 8100 minus 8100. The last term here, the negative 8100, will multiply by our leading coefficient negative 2, such that we have 16,200. Finally, completing the square, x squared minus 180x plus 8100 gives us x minus 90 all squared. So, we have our maximum area, which is 16,200 meters squared. We have our dimension for x, which is 90. And therefore, if we substitute 90 into our function right here, we can determine what y is. When we do so, we have 360 minus 2 times 90, which is the same as 360 minus 180. And we have a dimension of y, which is equal to 180. Finally, we need to check our solutions. We would have a maximum area of 16,200 meters squared. We would have a width of 90 meters and a length of 180 meters. And we are correct.